Okay, wearables. So nobody believes in a wearable banana. Why? Why can't we do a wearable banana? We should be able to do wearable everything, right? Well, no. I mean, it's not that simple. Wearables are there's something that you have to get right. There's a lot of finesse to it. It's accuracy is important. Form factor is important. It has to feel right. It has to work within our sensibilities. Nobody believes this wearable banana, and also just looks like vaporware. It's just like they projected some things on a banana. They're latching themselves onto a fad. Wearables is really challenging right now. There's been a 30% abandonment rate in all the wearable technology, like Fitbit and things like this, over a 6-month time period in 2014. 30%. So something's not right. There are people who are on the forefront, some of our speakers tonight, who are working to get it right, but we haven't gotten there yet. And so that's what we're talking about tonight. As far as our agenda goes, we're going to start off with a couple announcements, and but for those of you who are new, welcome to IoT Minneapolis. We are who are we? We're basically we're a group that convenes on a monthly basis to talk about disruptive business models, which are a result of the oncoming wave of technologies and sort of cultural trends, the maker movement, the kind of creative culture that's emerging. And we're all entrepreneurs. We highly value entrepreneurship and innovation through entrepreneurship. So we're here to support each other, to network, and to listen to some of the people who are on the front lines trying to make some of this Internet of Things technology work. So I guess we'll start off with some announcements. I always like to give people the ability to announce, I guess we have Justin here, and then we have Natalie here. If you guys want to come up here, I'll just keep talking for a second. But I always want to give people the ability to plug what they're doing that's related to IoT and related to entrepreneurship and makers. So if you have something you want to announce at this meeting, let me know, message me, and we can deal with that in future meetings. So first announcement is for IoT Fuse. I'll hand it over to Justin here. Here you go, Justin.
Thank you, Patrick. I think I probably talked to everybody here, hopefully. If I haven't, come and see me afterwards. There's a conference called the IoT Fuse, Internet of Things Fuse, going out to the University of Minnesota on March 19th. We've got 25 speakers. Mohammed here is one of our keynotes. We've got we'll be a bunch of sponsors. We'll be doing some giveaways at the end of the day. Should be a lot of fun. Should be a lot of fun. Actually, I think Caitlin too there might be another guy. Yep, speakers. Any other speakers here tonight? Who's speaking on it? But yeah, it's like Patrick said. Basically, it's in that same vein. We're trying to bring together people that are makers, people that are entrepreneurs. But the fusion concept is also people that are kind of thought leaders and kind of business, larger industry people as well. So should be a fun day. Should be a fun day. Come see me afterwards. Website is iotfuse.com. Hopefully everybody's got their little piece of paper that I gave out at the beginning, and thank you.
Thank you very much, Justin. So for those of you who don't know Justin, great guy. Founded Arduino.mn, which is a really great group. They get together on first Thursdays of every month, and it's much more about hacking and putting things together. So definitely encourage you to check that out. And next, we've got an announcement here from Natalie about a hack day that's happening on here at this location. So here you go, Natalie.
Hi everyone. Does anybody celebrate Pi Day? Couple, yeah? Yeah? I used to celebrate Pi Day every year in high school with my friends, and we celebrated it by going and getting pie, which is, kind of cool, but this year it's actually 3-1-4-1-5, so come on, that's the coolest Pi Day. We gotta do something cooler than going out and getting pie, right? So I figured, along with a bunch of our friends who are makers and hackers and inventors and designers, we're in a group called Co-Create. So we're together to create together and to inspire each other and to give each other the things that they need to create and to make cool stuff. So why wouldn't we do a celebration on Pi Day? So that's what we're doing, and that's what I hope that some of you will be interested in doing as well, because we're going to start the celebrations here. And we'll have a earlier in the day time where people can present things and share some of their ideas that they're doing, kind of like an adult science fair or an inventors fair. And we're also going to be hosting actual making shit time, like hackathons, across the city, so not just here. There will be people making stuff here, and those rooms are available for doing that here that day. There's also people who are going to be participating around town. And since Pi Day is a significant ways out, hopefully some of those people will be you guys, because I am making this announcement not to you just as people who would be participating in the event, but people who would be participating in the event by suggesting ideas of things to do and where to do them, offering space, telling your friends, and contributing whatever ideas or projects that you have to this day. And we really want to make it a dual city, Midwest, whoever we can get region of just everybody celebrating Pi Day in the way that makes sense for them. So if you're interested in being a part of that or being involved, talk to me after this, and I can get your info. Otherwise, you can go to cocreatex.com, and we have that as an event there, and you can learn more about our group. We can get you on Co-Create as well. So Co-Create is a website where we feature people who are doing cool stuff in the cities, which is probably a lot of you. And it's anything. You know, we've got companies that are design companies and engineering people, but then we also have people who are acrobats and hula hoopers, and we've got a potter up there. So it's just a really great group of people, and really we're all united just by the sense of possibilities. So yeah, talk to me.
Thank you, Natalie. Yeah, I definitely encourage you to check Co-Create out and participate in our Hack Day. We are trying to build not only a meeting group here, but a way to physically get people to do things here. So we're partnering with Co-Create. A lot of great engineers and artists from around the Twin Cities are coming together to create something very, very special. So I encourage you to check that out. Thank you very much, guys. So next up, I'm just pull up this and make sure I'm not forgetting anything here. IoT Minneapolis shirts. I don't know if that should be a thing or not. I figure because it's Wearables Night, I should ask that. Would anybody interested in that thing, at some point in the future? 1,
Only
2,
if it had a good pun.
3, 4, 5, 6. And as long as it had LEDs on it? Is that what you said? Okay, so maybe it'll happen, maybe not. Just let me know, message me if you have any ideas about that. It's just something that popped into my head. Okay, so now we'll move on to our first speaker here. Let me get the presentation ready for you here. How do I do this? I really should learn how to use a Mac before I use that as my presentation device here. Okay, is this the one? There we go. Ooh. Okay, so first speaker we have Crystal Compton from the University of Minnesota Wearable Technology Lab, and she's got some amazing things to show us. She's got a really, really great background in both technology, design, and in the actual fashion selling space as well. So let's all give a warm greeting to Crystal.
Hi everyone. Well, I am going to talk a little bit about what I do today in my lab, the Wearable Technology Lab, and then a little bit about wearable technology in general and kind of maybe where it's headed, and then a little bit about what I do and my experience. So pictured here is the Wearable Technology Lab where I work. What we do here is basically we try to combine apparel with the new technology. in simplest terms. So what is wearable technology? I think that's a really broad question, and I think that it can also have different definitions and mean different things to different people, but here is just one definition that it can have. Technology that is mounted on the body, usually without any manual support and for an extended period of time. And that technology can be electronic, mechanical, or textile. So here's another definition, an information processing device, and it's kind of always on, always ready, and just ready to go. And the technology here is information processor. So here is a framework of ubiquitous computing, also known as Internet of Things or pervasive computing. And as you can see, it kind of uses three different aspects of it, or it has three different parts to it. So you have wearable computers over here, which is like Google Glass, and then over here you also have smart clothing, which is also known as e-textile sometimes. And then a rather large portion of it that people often sometimes don't think about or realize is functional clothing, and that's down here. And functional clothing is kind of designing for performance needs and its user requirement. It's about understanding the human body and kind of how clothing interacts with it and the environment as well. And then over here on the left-hand side is a functional clothing design book, actually written by my advisor, Dr. Lucy Dunn and Susan Watkins. It just got published about a month ago, and it's a really fascinating read, and it really provides a lot of information about understanding clothing and how it works on the body, and providing new ways of looking at clothing, the environment, and the body. So here is a graph kind of wearable technology, where it's been, where it is now, and kind of where it's headed a little bit. So we have these two things, both accuracy and comfort. And in blue we have the existing technology right now, and then in green is kind of the current research, kind of trying to blend both that accuracy and comfort, and then in yellow, kind of the future progress and a little bit of where we're headed. So this is a stretch or bend sensor that we develop in my lab. It uses common apparel machinery and conductive thread, and this particular stitch uses a cover stitch machine. So a cover stitch is one that you'll often find on the hem of a t-shirt or any sort of stretchy shirt. So it's very common and it's easy to make, it's non-invasive, it's very minimal, and it's comfortable too. So we use this sensor or stitch, and here is kind of a sample of it. You guys want to, should I pass it around? I don't know. So it's used a lot of times. This was kind of my demo. Essentially, we're able to sense the body. Well, I'll get right into it, or I'll get into it later, but we're able to sense the body. And here it shows if it's stretched, it makes a different noise, but it's not really working, so unfortunately I don't have that demo. But it can be applied to a lot of different things. And the way it works is it has a complex loop structure, and when that sensor is stretched, the loop structure changes, and we are able to measure that and get a resistance change from it. So here's a picture of it in its relaxed state on the left-hand side, and then in its stretched state on the right-hand side. So you can kind of see a little bit of how that loop structure works. And then this is a graph of the signal, or the sensor signal. So in purple we have the extension of the sensor, and then in red there is the resistance. So we hook the sensor up to a digital multimeter to read the resistance, and then to stretch the sensor we used an Instron machine. So it kind of has just like two different clamps, and then it stretches the sensor in a very repeatable and controlled way. So now that you know a little bit about what I do in the lab, I kind of want to give you just a very brief bit of information about where I came from and what has led me to here. So I got my Bachelor's of Science in apparel design, and this is kind of like our thesis or senior line of our bachelor's degree. And so from this degree, I have been able to learn how to design for the body and understand the body and how it works and what it needs. And not only design for the body, but design for it aesthetically and functionally, which I think is really important to do. Right here is a picture of my group. I was a part of a group about a year ago that was accepted into NASA's Reduced Gravity Education Flight Program. And so what we did was we basically studied astronauts' hands. Astronauts have to wear something called a liquid cooling garment, which regulates their body temperature. However, it does not extend to the hands because there's not enough room. So astronauts' hands get really sweaty and sweat builds up, and they get things like fingernail delamination, and it's not really fun or pretty. So we researched and studied different materials and different methods of kind of eliminating that sweat. And we tested it in both Earth gravity and then in zero gravity through parabolic flight. This is another NASA project that I worked on that was in the Wearable Technology Symposium that is at Johnson Space Center every April. And this garment was made to kind of detect and prevent spacesuit injuries because astronauts have to wear really hard and bulky and rigid equipment. They get a lot of injuries from that during their trainings, obviously. So our mentors at NASA wanted to know where these injuries are occurring and to what degree. So we developed soft switches, and they just use a spacer fabric, and then we put different sized holes in problematic areas, and then a layer of conductive fabric on each side. So essentially, once enough pressure was applied to these areas, then the switch would close. So this is a project that I'm currently working on. It's more of a medical approach, and the garment is ideally supposed to be for patients with scoliosis or kyphosis. And so I use the sensor that we've developed in our lab right here using conductive thread. And then later on, I will also be implementing an array of magnetic sensors to kind of get the XYZ plane of the spine. And ultimately, this garment should be able to minimize doctor visits for patients, but more importantly, not only that, it also would limit exposure to radiation for patients. And last but not least, this is a project that was accepted at the International Symposium of Wearable Computers 2 years ago, and I call it the world's sexiest knee brace, because it is a more, and here is a live view of it. So this is more of an aesthetic approach to a typically bulky and cumbersome knee brace. The way it works is there is a sensor placed along the backside of stockings, and then all the electronics are up at the top, as well as a vibrating motor. So when there's a threshold of the degree of knee bend, and when that threshold is reached, it essentially buzzes the user and alerts them to stop bending the knee. So it's more along the lines of retraining the brain and retraining the muscles rather than simply restricting the user. And I think it's very interesting, and it kind of asks new questions and kind of gives insight to what is possible and where we're headed in the future. And that's it. Thanks. Any questions?
What is the sensor measuring that you're passing around?
We've typically measured it or used it to measure kind of body movements and body positions. So that's kind of what we have used it for at the moment. We're able to get, like I said, a change in resistance when the sensor is stretched, and so that's kind of what we've used it.
Stretch versus relaxed.
What was that?
Stretch
stretchy versus this is stretchy a bit more.
Yep. Yep.
So what if men have a problem, or they want to have like a thing like that, but maybe not so lacy and kind of frilly? Is it are you working anything like that?
I suppose we could make something like that. If it's just the lace that you're worried about, we could definitely fix that. But if it's the stocking in general, I think we might have to take a little different approach.
Then maybe I can whisper.
Can you elaborate a little more on where Wearable is heading to? I mean, in a sort of high level way, is there certain industries that are in need of this more? Is there certain universal pain points that are becoming more obvious? Is there certain technologies that are being applied more, so on and so forth?
As far as where it's headed, at least for me, I think it's kind of the seamless integration into our everyday lives and into stuff we're wearing, or just the seamless integration into our lives, basically, I think is where we're kind of headed, or at least where I am headed. I think that a lot of people can use it. I think that's, I guess, where it's headed, and kind of bridging that gap of comfort and accuracy, and kind of having it be almost non-existent, but still there.
One more question.
How important do you think the combination of fashion and utility will become in wearables? Or do you think it's more important just to get it out there first, and then think of a user preference and fashion brand partnerships and such as a next level step, or would you come out with that right away? For example, branding this with Nike or someone.
I don't know if it's necessarily important to brand it right away. I guess I'm not really on the business side of things, so I'm not really sure about that.
That's fair, yeah.
But as far as, were you asking about what's more important, like functionality or the aesthetics?
Yeah, I guess that's it. And people are going to really adapt it or adopt it early. If it's uniquely utilitarian.
Well, I think that it's specific to each different thing. I think that some things are meant to be more functional and less aesthetic, and some things are meant to be more on the aesthetic side. But that's why I say I think it differs for each individual thing. I think it's unique. Does that answer your question?
That's great. Thank you.
Thank you.
Last question.
Oh, one last question here. I'll help with this.
What would this cost, like per length? How feasible is this technology that you're showing around? The stretch sensor?
Oh.
It's fairly inexpensive. We have a large spool of conductive thread, so basically it's just the cost of conductive thread in your sewing machine. I think we got our spool of thread from SparkFun for maybe like $150, which maybe sounds like a lot, but it's a big thing, and it's lasted us for years so far. So it costs a lot maybe up front, but for each individual piece, it's not very expensive.
All right. Thank you very much. Let's all give a hand to this. Thank you. We just have to keep rolling on here. So my understanding of what the University of Minnesota is doing in their Wearable Technology Lab is it's much more about fundamental materials research. It's about getting things that don't exist at all and getting them built. The U of M also has a Office of Commercialization of Technology, and so if you're interested in figuring out, oh, what are they doing over there and how do I commercialize this? If you're more on the business end of things, that, you know, there are people over there that are very good at that and could answer that type of thing as well. So maybe I could get them in here in a future meeting. But what they do over there is amazing. I encourage you to check out their website, and thank you very much, Crystal. Okay, next we have Samir Kumar. Samir, I met at actually Justin Grammon's founded the first Internet of Things Hack Day. He's the guy who was talking about IoT Fuse earlier. That was back in October. So I met Samir and did a little bit of help on his team, not really too much. It's been a really good time knowing him, and he's a very talented gentleman. I'll let you introduce yourself more and introduce your idea.
Great.
Oh yeah. Oh yeah.